Hello students, welcome to maths class. We are dealing the topic ellipse, right? We completed the parabola and now we are in ellipse. So what is ellipse? It is nothing but a conic section. It is a part of conic section. If we cut the cone, right, with a plane with a different angle, we will get three shapes. One is parabola, one is ellipse and another one is hyperbola. And what is the geometrical condition satisfied by the point on these three curves is, I said SP by PM is equal to E, and E is called the eccentricity, right? If E is equal to 1, it is a parabola, E is less than 1, it is ellipse, and E is greater than 1, it is hyperbola, I said, right? So now from this ellipse you are going to get two short answer questions, right? Two 4 marks questions. Okay, so now first we will go to one theorem for today. Okay, so come to the first question. If p x comma y is any point on the ellipse, x square by a square plus y square by b square is equal to 1. What I said? It is a standard ellipse form. X square by a square plus y square by b square is equal to 1 is called the standard ellipse form, right? So and here I said in one case A is greater than B and another case A is less than B. In standard form generally A is greater than B. If it is not mentioned anything, you consider the ellipse equation means first form. First form means x square by a square plus y square by b square is equal to 1, where A is greater than B. Okay, so here whose foci are given to us S and S dash, then prove that SP plus S dash P is equal to constant. This is the theorem we have to prove. If we take the standard ellipse equation and there are two foci S and S dash will be there and P is any point on the ellipse, then we have to prove that SP plus S dash P is a constant, some constant value we have to prove. So now come to this. This is your ellipse diagram. I said it is oval shaped elliptical diagram, right? Two foci will be there. S and S dash are the two foci and ZM and Z dash M dash are the two directrices of your ellipse. Okay, you consider one point P x comma y on this ellipse. Okay, so first we will write what is the ellipse equation. So equation of ellipse. Equation of ellipse is standard form. What is that? X square by a square plus y square by b square is equal to 1. Here your a is greater than b. Okay. So now what is the given information to us? S and S dash are foci, right? And directrices, what are the directrices? We can take ZM comma Z dash M dash are directrices, isn't it? So directrices of ellipse. Okay, so these are the two directrices of the ellipse and P x comma y be a point, isn't it? P x comma y be a point on ellipse. So now you join PS and PS dash. Actually our aim is we have to prove that SP plus SP dash is equal to constant. So from P to join S as well as S dash. Okay, so join SP and SP dash or PS and PS dash, both are same. Join SP and SP dash. That means we are joining S and P and S and P dash. Okay, and draw a perpendicular. Draw a perpendicular. Which perpendicular? PN. Draw a perpendicular PN on x axis. Okay, so draw the perpendicular PN on x axis. Now by definition of ellipse, right? So you know that all conic sections SP by PM is equal to E. That is the geometrical condition. From the definition only, for parabola, if you take ellipse, if you take hyperbola, what is your geometrical condition by definition? SP by PM is equal to E. But E, according to E, your shape of the curve changes. So, by definition of ellipse, it is SP by PM is equal to E. Okay. So, implies send PM that side, SP is equal to E into PM. Now, observe your diagram. Where is your PM? So, this is your PM. Okay. So, PM is nothing but NZ, isn't it? That's why I have taken the perpendicular PN on x axis, isn't it? This is your x axis, this is your y axis. Okay. So, I have taken the perpendicular PN on x axis. So, now if you observe, your PM is exactly same as NZ, isn't it? The distance PM is exactly same as NZ. So, in this PM place, I will write NZ. Again observe NZ. What is your NZ? So, this is nothing but the distance from CZ minus CN. See, from here to here minus this distance CZ. Right, from here to here, then minus Cn, this distance, nothing but this distance Nz only. So, instead of Nz, we can write, come on, how we can write, which values we can write? Nz is equal to Cz, right, minus Cn. Observe the diagram carefully, entirely this theorem proof depends on the diagram, right. So, draw the diagram correctly. Okay. So, Cz minus Cn. Now, come to Cz. What is this Cz? This is the distance, right. What is this directrix equation? X is equal to A by E. What is the meaning? From the origin to this line, the distance is A by E. That is the meaning of X is equal to A by E. On the line, wherever you take X value, that is A by E. X coordinate means the distance from origin to that point. So, this Cz is nothing but A by E, and Cn, this is your Cn. Cn is nothing but exactly same as your this distance, isn't it? So, this is nothing but from P to we draw the perpendicular to y axis, perpendicular to x axis. This is your x, this is your y, isn't it? Observe the diagram carefully. P x comma y. From that point, draw the perpendicular to y axis. That is your x coordinate of the point x. This distance is exactly same as this distance. So, this is x. So, your Cz is A by E and your Cn is x. So, we will substitute here. So, E is equal to, what is Cz? A by E, the distance from origin to directrix, and Cn is nothing but the x coordinate of the point P. Okay. So, this is with respect to P and this foci, right. Another focus is also there, S dash. So, by definition, again by definition only, isn't it? So, what is that? It is S dash P by P M dash now is equal to E, the distance of the point from the focus, isn't it? And the distance of the point from the directrix maintains a constant ratio. That ratio is called eccentricity. That is the definition of conic sections, and that is the definition of ellipse. Okay. So, come on, here we can write this as S dash P is equal to E into PM dash. Okay. So, now observe your diagram. Okay. So, it is E into PM dash. So, entirely this proof depends on the diagram PM dash from here to this distance, total this distance. So, can we take this distance as this distance plus this distance, isn't it? This plus this, that means Cn plus nothing but CZ dash, isn't it? So now again by the definition of ellipse, S dash P by PM dash is equal to E. Okay, send that PM dash that side and observe PM dash is nothing but exactly the distance of NZ dash. Okay, let me write clearly, it is NZ dash. Again NZ dash can be taken as Cn, this distance, plus Cz dash. Okay, so it is nothing but Cn plus Cz dash. E is equal to Cn. So see here, Cn, already I said to you, this is exactly same as this. This is nothing but our x, small x. Next it is Cz dash. What is this? It is nothing but the distance from center to directrix. Already I said to you, center to directrix is A by E. So it is left side, that's why this line equation we will write x is equal to minus A by E. But if we take only distance, it is nothing but A by E. Okay, so Cn is x plus Cz dash is distance from center to directrix, that is A by E. Okay, now you take your Sp plus Sp dash. You got your Sp value as well as S dash P. So in the theorem it is given that prove that Sp plus S dash P is equal to constant. So come on, now you take Sp plus S dash P. So is equal to Sp E into A by E minus x plus E into x plus A by E. Okay, so is equal to E into A by E minus Ex plus Ex plus E into A by E. So minus Ex plus Ex cancel, here EE, here also EE. So it is A plus A is equal to 2A. Letters are constant and numbers are constant. Constant into constant, constant only. So you got Sp plus S dash P is equal to 2A is equal to constant. So hence proved, we have to write, this is a theorem, right? So you have to write hence proved. So very simple, by the definition of ellipse we have taken the geometrical condition with two focus, right? First focus and point, and second focus and point. First focus Sp by Pm is equal to E. Second focus S dash P by Pm dash is equal to E. With that you got your Sp value, S dash P value. Okay, then you take Sp plus S dash P, you will get your answer. Okay, so try to draw the diagram carefully. How simple diagram it is, normal ellipse, right? Two focus will be there, S dash, and two directrix will be there. Okay, next you take one point on the ellipse, Px comma y is a point on the ellipse. Okay, so after that you draw the perpendicular from P on x-axis, Pn perpendicular on the x-axis. Okay, join P and S and P and S dash. Okay, join P and S and S and P dash, S and P, S P dash, right? Join them, these 2 points and these 2 points, join them, right? After that, by definition, you can prove your theorem. Okay, so now come to the second question. What is your second question? Find the equation of the ellipse in the standard form such that distance between foci is 8. Distance between foci is given to us and the distance between the directrix is 32. Okay, so come on, what is the equation of ellipse in standard form? Equation of ellipse in standard form is, you know it very well, x square by a square plus y square by b square is equal to 1, where a is greater than b. What is the given information to you? Given that What is the given information? Distance between foci, right? So distance between the foci is equal to 8 is given. Okay, so distance between foci means here this one. What are the points? You know it very well. AE comma 0, S is equal to minus AE comma 0. Actually this point is left side of Y, that's why we have taken minus AE. But if we take the distance, this is AE and this is also AE. So the distance between the foci, right, is 2AE. Okay, so come on, 2AE is equal to 8. So 2 ones are 2 fours implies AE is equal to 4. You consider this as equation number 1. What is the second information given to you? Given that distance between the directrices is given to you. Distance, right, between the directrices is given as 32. So again what I said, x is equal to a by e is one directrices. This is the standard form of your ellipse equation. So what is the directrices? X is equal to a by e and x is equal to minus a by e. But actually y here we have taken minus means this is left side of y axis. But if we take the distance, this is the directrix maintains the distance of a by e, and similarly this directrix from the center is nothing but a by e only. So the distance between these two means 2a by e, right? 2a by e is equal to 32. This is the given information to us. So 2 ones are 2 6 are. So a by e is equal to 16. You consider this as your second equation. Now you take 1 into 2. What happens to your value? It is AE into a by e is equal to 4 into 16. Okay, E cancels. So it is a square is equal to 16 fours are 64. Okay, so we can write this as a square is equal to 8 square implies a is equal to 8. Okay, so actually question is find the standard ellipse equation. So at the end we have to write x square by a square plus y square by b square is equal to 1, where we have to find a and b values from the given conditions. Two conditions are given to us. One condition is distance between foci is given to us. Another condition is distance between the directrices is given to us. By using these two conditions, you find out your a and b, then substitute. That will be your standard ellipse equation. Just like in circles, we will take general circle equation, it passes through, that means some conditions will be given. By applying those conditions we got G, F, C, then we substituted. Same thing here also, you take standard ellipse equation and you take the conditions. From the conditions you find out A and B, at the end you substitute it. Okay, so how we got a value, now we have to get a b, right? So how we will get it? We know one thing, we know that there is one formula. What is that? B square is equal to a square into 1 minus e square. So again this can be written as, if we open the brackets, it is a square e square. Again it can be written as a square minus ae whole square. Okay, so come on, b square, therefore b square is equal to, we got a square as 64, right, minus ae as a 4 square. Okay, so 64 minus 16, that is 48. So to write the ellipse equation, we want a square value and b square value. We got a square as well as b square. So therefore required ellipse equation, right? What is that? ellipse, standard ellipse equation is x square by a square, we got 64, right, plus y square by b square, we got 48 is equal to 1 is the answer of your question. Okay, so very simple. Two conditions are given to us. By using those two conditions, find the standard ellipse equation. That is the question. So, just you take a general or a standard ellipse equation, right? You know it very well. Not only here, in any class, ellipse equation means we have to go for standard form, that is x square by a square plus y square by b square is equal to 1, where a is greater than b. Okay, so distance between foci is given to us, so it is 8, and you know that distance between foci is 2ae, right? So with that we got ae. Similarly, distance between the directrices is given as 32, so 2a by e is equal to 32, right? So simplify, you get your a and b values, substitute in the standard form, right? After getting a square b square, you substitute in the standard form, you will get your required ellipse equation. Okay, so one is theorem, we have to give the proof, and second one is normal question. Two conditions given, you have to find standard ellipse equation. Okay, practice these problems perfectly. Have a nice day. That's all for today.